Hello, my name is Max Kreminski, and I'm a computational media PhD candidate at the University of California, Santa Cruz. Today I'm presenting Blabrecs, an AI-based modification to the word game Scrabble. Scrabble is a game of letter tile placement. Each player receives a hand of 7 random letter tiles drawn from a bag, which they place in a row or column on a grid of squares to form a valid English dictionary word. Each word has to build off of another previously placed word, so you gradually end up building up a crisscrossing network of words on the board, sort of like a crossword puzzle. The letter tiles that you place are scored by how common or rare the letters are, so that you get more points for using less common letters, and by score modifiers on certain board squares that double or triple the value of a letter or word placed on that square. In creating an AI-based Scrabble modification, we had a few different design motivations. First of these is that Scrabble's design promotes dictionary memorization, for instance, memorizing a list of words that contain a Q but no U, rather than more interesting kinds of wordplay, such as making up your own words. From the other side, AI-based spelling and grammar checkers and other sort of autocorrection algorithms can often be really frustrating to work with. In both of these cases, the frustration stems in part from the fact that there's an external authority being imposed between you, either as the user or the player, and your own language. In the case of Scrabble, that's the English dictionary. And in the case of these AI-based systems, that's an artificial computer system that's telling you what counts as a valid word or doesn't. And so we really wanted to see, like, what would happen if we made a game about that experience. In the creation of Blabrecs, we had 2 major sources of design inspiration. One of these was Rewordable, another card-based word game by Alison Parrish and a few other people. The designers here used a combination of manual and algorithmic methods to slice up the English language into a bunch of different phonetic rather than letter-based tiles, which in turn enables Scrabble-like word-making gameplay without some of the tedious corners of this play space. For instance, the dilemma of what do you do with this sort of isolated or lone Q tile. We were also looking at the tabletop game Dialect by Thorny Games as a source of design inspiration. In this game, players work together to construct a shared language and the story of the community that uses that language. The language itself ends up becoming a shared artifact with meaning only to the members of the group that created it, and dies implicitly as the members of that group dissipate. And both of these led us to the question of whether we could use AI to create a Scrabble-like game in which gameplay revolves around making up new words. And as you can see, the game we ended up creating is called Blabrecs. The main interface for Blabrecs allows you to type in a word to be tested. And in this case, we can type in, for instance, a real English dictionary word, such as plum, and see that the system is telling us there's no way we can play that. It's in the dictionary. So the first thing that you see here is that actual English dictionary words are rejected because they're not valid for play. However, what if we type a word like, I don't know, some nonsense, something like Wexel? In this case, the system judges this by its letter frequency combinations and goes, no way that's a word, because these syllables and these characters don't appear together frequently in the corpus of actual English dictionary words. So it judges this to be impossible. But what if we try something again, like Ulyss, for instance? In this case, the system says, looks good to me, because this passes the test for legitimacy, and therefore is allowed as a viable made-up word to be played. So we go ahead and play it. And you can see here that we've got a table now with, on the left-hand side, the word that we've just sort of created. And on the right-hand side, a text box where its meaning can be entered. And in this case, we're going to say that Ulyss is a noun, and that this definition is an egg-shaped room, storage shaped objects. And so now play would pass, as in Scrabble, to the next player, and they would use the words or the letters that they've been given to try to create another word, and so on and so forth, with all the players having to find a way to get their words past the judge that's been implemented here. There's actually 2 different modes of judging that can be used. So you might remember that the word Wexel, as we tried earlier, is not valid according to the Markov chain-based classifier, which is sort of the default classifier and the first one we created in making Blabrecs. But if you switch over to the neural classifier created by my friend Isaac Karth, you can see that in this case, Wexel looks good to me, and this word can now be played. And as you can see, you can sort of go on defining these words, playing them on the Scrabble board, and maintaining sort of an active Scrabble session using Blabrecs, this sort of AI-based judge, as the arbiter of what counts as a valid word, rather than the English dictionary, as you would in a normal game of Scrabble. So yeah, that's Blabrecs. If you'd like, you can read the paper to learn more about the system. You can come talk to me at the poster session. You can play it yourself in your own web browser. And also, if you want to come talk to me about it more, I'm on Twitter at Max Kreminski. Thank you.